Welcome back. Before we jump into the ethics of it all, we were really digging into the idea that making a digital copy of someone's mind isn't as simple as just copying files. It's about capturing their essence.
Yeah, that really stuck with me.
Which is a far more complex and challenging undertaking.
It's like my computer can hold millions of photos, but it doesn't understand the emotions tied to those memories, the way I feel when I see them.
Exactly, and that's what the authors of this PNE article highlight as crucial: the affective charge. It's the emotional weight, the personal significance we attach to our experiences.
Right.
It's what makes a memory yours.
And this charge comes from the limbic system, right? That ancient part of the brain that handles emotions and instincts, the stuff we share with other animals.
Precisely. And it's the interaction between this ancient limbic system and the more recently evolved neocortex, the part responsible for higher level thinking, that creates the symphony of your unique mental experience.
So if we're aiming to recreate someone's mind digitally, we can't just focus on their thoughts.
Right.
We have to understand the deep emotional roots of those thoughts. Like, you can't appreciate a painting without understanding the artist's emotions and inspirations behind it.
That's a great analogy. And to take it even further, to truly understand that artists, you might need to look beyond their finished work and delve into their sketchbooks, their early influences, even their dreams. The authors argue that's how we need to approach PNE, understanding the whole person, from their earliest experiences to the complex interplay of brain regions that make them who they are.
Okay, this is where my brain starts to get a little fried.
Yeah.
If we're talking about capturing someone's entire mental history, wouldn't that require, like, a lifetime's worth of data? How could we possibly collect all that information?
Well, that's where the article gets really interesting. The authors suggest focusing on sleep, specifically those later stages of REM sleep where our brains consolidate our most fundamental memories.
Wait, so our dreams are actually key to understanding who we are?
Yeah.
It's like saying our subconscious holds the master key to unlocking our true selves.
That's the idea. The authors point out that research suggests those deep REM sleep stages are heavily influenced by the limbic system, the seat of our emotions and primal urges.
No, it's like our dreams are this playground for our deepest selves, where our emotions run wild, processing experiences and weaving them into the fabric of who we are.
Precisely. And the authors believe that by capturing high-definition EEG data during these sleep stages, we might gain access to the emotional core of a person's being.
Wow, so it's not just about copying facts and figures. It's about recording the dreams, the emotions, the raw, unfiltered essence of what makes someone unique. This is starting to feel less like science and more like poetry.
And that's what makes this whole concept so fascinating. It's a fusion of cutting-edge science with these profound questions about the nature of consciousness, identity, and what it truly means to be human.
All right, so let's say hypothetically we could capture all this incredible data, the thoughts, memories, and emotions. What then? How do you go from raw brainwaves to a digital consciousness?
Well, that's where AI comes into play. The authors propose that advanced AI, specifically AI capable of a process called active inference, could be the key to decoding and interpreting this vast amount of brain data.
Okay, remind me what active inference is again.
Imagine your brain as a master predictor, constantly creating models of the world based on your experiences. Every new piece of information is used to refine that model, to make more accurate predictions about what will happen next. That's active inference. And the authors believe AI could be trained to do the same thing with brainwave data, to learn the unique patterns of an individual's mind and predict how that mind would respond in different situations.
So it's like having an AI that can learn to think like you, anticipate your reactions, even make decisions based on your personal values and beliefs. That's pretty incredible, and maybe a little scary.
It certainly raises some big questions about the nature of free will and identity, but the authors argue that the potential benefits of PNE are enormous.
Okay.
Imagine being able to preserve the minds of brilliant scientists, artists, and thinkers to continue learning from them long after their physical bodies are gone.
What about the ethical implications?
Yeah.
If we can create digital copies of people, what rights do those copies have? Are they considered individuals? Could they be exploited or manipulated?
These are exactly the right questions to be asking, and that's why it's so important to have these conversations now. Before this technology becomes a reality, we need to establish ethical guidelines and frameworks to ensure that PNE is developed and used responsibly.
Okay, so we've gone from the mechanics of the brain to the potential of AI to recreate consciousness. But what does all this mean for us, for humanity as a whole?
Yeah.
What happens to the idea of self when our minds can exist outside our bodies?
Well, that takes us to the heart of the philosophical implications of PNE, which are perhaps the most mind-blowing of all. And that's exactly what we'll be diving into in the final part of our deep dive.